This is Algebra 2 with Trig, 8C.1c. We're specifically talking about the ambiguous case for law of sines today. Some different thoughts. Anytime you have two triangles, and we're working with angle, angle, side, or angle, side, angle, if we're working with one of those situations, then you're going to have one triangle. You don't have to worry about all this extra consideration. When you have two sides and one angle, the non-included angle, we have to be careful. If the given angle is obtuse and the side opposite is smaller, then there is no triangle. If it's obtuse and the opposite side is longer than the extra side, then there would be one triangle. If you're doing your work and you get a domain error when you're first trying to figure out an angle, there is no triangle. But if you get an answer, then you're going to have two triangles. So let's try this. We're going to come down here. We notice that we're working with an obtuse triangle, 127. Side A is going to be across from the 127. Side B, I'm suggesting to always put it so we're working clockwise around the triangle. Always put it there. Don't come down and set it here. You can mathematically, but this will help you dramatically. So, is the opposite side greater than the other side? Yes, it is. So we know we're going to have one triangle. So we're going to go ahead and find these other pieces. Angle B, if that's A, angle A, B, angle B, so this has to be C with side C. So what's the first thing I have to solve for? Angle B. So I'm going to do sine of B over side B and sine of A over side A. I don't know what sine of B is, but I know that the side is 42. Sine of 127 over 63. I'm going to cross multiply. And when I do that, I get 42 times the sine of 127. And I divide that by 63. And I get an answer that is less than 1. This is a requirement. If you get an answer greater than 1, there's no triangle. That might come up in the future. We got an answer that was less than 1, so there is an answer. So we're going to do sine inverse of our answer of our 0.5324, and that gives us a 32.17 as an angle. The measure of angle B equals 32.17. So what are we going to do next? So we're going to find the other angle. So we take 180 and we subtract our 127 and we subtract our 32.17. 180 minus 127 minus our 32.17, or answer, that would be fine also. And we get 20.83. That's the measurement of angle A. 20.83. What do we need to do from here? law of sines. We have to solve for side C. So I'm going to put C on top because that's what I want to solve for. My side I don't know. And I'm going to use the A fraction. You could use the B fraction if you want. I like the A fraction because my numbers are so simple. So I'm solving for C. Sine of 20, 83, 63, sine of 127. And we cross multiply. 63 times the sine of 20.83 divided by the sine of 127. Gives us a length of 28.05. .0805. Now let's think about this for a moment. The largest angle, 127, is across from the longest side. That makes sense. The medium size angle, 32, is across from the medium side. And the smallest angle is across from the smallest side. That's going to be a requirement. That'll always happen. It's a good way for you to check your work. Do you have something in the wrong spot? All right, number 2. Here we have 52-degree angle. Side B. Now watch here. We're using the letter B for the angle, so some of the formulas get messed up. 4.7 is our opposite side, and the other side is 6.5. So there's two things that we can do here. We have a possible situation where we have either two triangles. We could have one triangle, or you could have no triangles. It all comes down to this situation. The opposite side for us is actually shorter than the side next to it, so this isn't an option, so we're down here. You could calculate what the height is to see what the height is to determine if this is long enough, or you could just pretend like you don't even know about that. So I'm going to do, let me write the letters out. I like to do that. A is going to be over here. I don't know if this really matches or not, but we're going to have sine of B over B equals sine of A over A. I'm trying to figure out what this A angle is going to be. So sine of 52 over 4.7 is going to equal the sine of A, which we don't know what it is, over 6.5. So far, so good. We're going to cross multiply. We only have to cross multiply one direction because our unknown is on top. So we have sine of 52 times 6.5, and we're going to divide that by the 4.7, and we get this answer that is greater than 1. Greater than 1, well, I could do my sine inverse of my answer. I get an error. You can't have a sine greater than 1. So what that's implying here is that this side is going to be shorter than the height. You can calculate that height if you want. Sine of 52 of this right triangle. You could calculate that. Sine of 52 equals opposite over hypotenuse. So you get h over 6.5. If you wanted to, you could say 6.5 times the sine of 52, and we get 5.12. That's telling you that this height is 5.1, but this length is only 4.7. It's swinging, and it's never going to touch 5.1. It's never going to make it. This hinted at it. This told us it was going to happen. We just didn't know what the height was. You don't need to know the height. This is good enough. No triangle. All right, let's come on down here and take a look. Little focus. So we have 62, something like that. Try to draw this somewhat proportionally. Maybe it'd be a little higher. The opposite side is going to be A, because this is angle A. The other side is going to be 34. So if you'd like, you could find the height, and you could determine what might happen here. If the height is shorter than 32, then this is going to touch in two different spots, because 32 is less than 34. Or you can just solve for the angle. Just use the law of sines, see what happens. So we get sine of B equals 34. That equals sine of 62 over 32. We're going to cross multiply in one direction. So what that's showing us is sine of 62 times 34, and we're dividing that by 32, and we're getting sine of B to equal 0.9381. And that means that that is a 69.74 degree angle. If this is a 69.74 degree angle and the opposite side is smaller than this, then we have to have a second triangle. We're going to be able to swing this back over. We have the 62. We have the 32 that swung this way. We have the 34. And we have this 69.74. How do I find this obtuse angle here? How would I find that angle right there? Well, this is 69.7. This is an isosceles triangle because the 32 is on both sides. So these are supplementary. So I need 180 minus 69.74. And I get 110.26. So that is the measurement of angle B of this second triangle, right? So now we have two triangles. We have two sides and two angles, two sides and two angles, and now we can find C for both triangles. We can do this by working with either triangle first. It doesn't matter. I'll come back up here. We're going to look for angle C. Well, we're going to get angle C by 180 minus the 62 minus the 69.74. That gives us this angle. Our calculator can help us do this. 180 minus 62 minus 69.74. That's the measurement of angle C. You want to label your work. 48.26. And then now we need to find side C. Well, side C over sine of 48.26 equals 32 over sine of 62. That's the C fraction over the A fraction, or equaling the A fraction. So we cross multiply. We get 32 times the sine of this 48.26, and we're dividing it by the sine of 62. So that's going to give us 2704. So that gives us all the information that we need. Two angles and our missing side for that triangle. That's an acute triangle. This obtuse triangle, well, again, we have to find angle C. So that's going to be 180 minus 62 minus the 110. Think about what that means. You have two angles. You're looking for the third angle, so you're going to use the 180 rule to help us calculate this. And that gives us a nice small angle of 7.7. And because this is obtuse, this swung inside and it made that angle really small. And that's why it's only 7.7. Now we have to figure out this side C, because if that's 7, this side C is going to be much smaller. When it's 48, this one's 27, but when this is 7, this is going to be much smaller. So C over sine of 7.74 is going to give us 32, the A fraction. So we cross multiply. That's 32 times the sine of 7.74 divided by the sine of 62. That is 4.88. Much smaller. So we found the two angles and the missing side for the obtuse triangle and for the acute triangle. So we can flip this over. These are ones that you should try. I'd suggest to pause the video, you work on it, and then you can turn it back on and I'll walk you through it. Here we'd have an obtuse angle of 122. We have this long side of A, which is 18. And as long as that's longer than this 12, it's got to be longer than the side next to it for an obtuse angle, then we have one triangle. So we're going to go about trying to find out all these silly values. The sine of B over 12 equals the sine of 122 over 18. I put the signs on top because I was solving for an angle. So I have sine of 122 times 12. I got to put that in parentheses. Super important to put that in parentheses. And then divide it by 18. And that gives me the sine of B equaling 0.5653. That's less than 1. That means everything's working out the way it's supposed to. So sine inverse of our answer gives us the measure of angle B to be 34.43, because I did the inverse of 0.5653. So that's 34.43. For me to find angle C, I'm going to take 180 and subtract my 122 and also subtract my 3443. And that gives us 2357. That's the measurement of angle C. 2357. So now we're only missing side C. So what are we going to do to find side C? We're going to use the C fraction and the sine of our 2357. Our A fraction, 18, over the sine of 122. And we cross multiply. So that gives us 18 times the sine of 2357. Close the parentheses, divided by sine of 122. And we get 8.49. Now we have all the information that we needed. Two angles and a side. Okay, let's see what happens here. (36° with angle A. The opposite side is smaller than the adjacent side. Okay, that means that there could be two triangles or there could be no triangles. Possibly one triangle, I guess. So we have to figure out what this height is, or we could just use law of sines. We could just do the math. But if we think about this as a right triangle with 36, a right angle, a hypotenuse of 12, and we're looking for the height, this is an option for you. You can do sine of 36 equals opposite over hypotenuse. We say 12 times the sine of 36, and we figure out that the hypotenuse is 7.05. Not the hypotenuse, sorry, the height is 7.05. 9 is going to fit in here twice. So I should be able to redraw this triangle over, this edge over, to be 9 on this side. So I'm going to end up having two triangles. I'm going to have a triangle that comes up at 36, comes in as 9. Let me write that the other way. A equals 9. B equals 12. This would have to be angle B, angle C, side C. My other triangle, kind of the one that we have drawn here, side C is longer. We still have the 36-degree angle for A. B is 12, and we swing out. So those are our two triangles that we're working with. That's because the height was smaller than our A. So our A is greater than the height, and it's less than our adjacent side. So we have two triangles. So we have to start here. Now, let's pretend for a moment we didn't find the height. We're just going to do these numbers. We'll just not even know about if it has two triangles, not two triangles. I didn't even consider it. I just worked with the numbers. So if you just work with the numbers, you get 9 over the sine of 36 equals 12 over the sine of B. Looks like I put my angle on bottom this time. No big deal. I just got to cross multiply and get 9 times the sine of b equals 12 times the sine of 36. And I'll have to come back and divide by 9 as that extra step. 12 times the sine of 36, close a parenthesis, divided by 9. That is giving me a value that is less than 1. That's a requirement. That tells me there's going to be 2 triangles. So you don't even really need to know that. You can just do law of sines to figure out if this exists. Anyway, sine inverse of 0.7837 is going to be 51.60 degrees. So this is 51.67. That's the measure of angle B. To find out the measure of angle C, take 180 minus our 36 minus our 51. And that gives us 92.33. So this is 92.33. Those are the 2 angles we've solved for. That's the measurement of angle C. Now we're going to find out side C. So side C over angle C has to equal 9 over sine of 36. Just have one cross multiplying we need to do. 9 times the sine of 92.33, close a parenthesis, divided by sine of 36, and we get 15.30. And there we have found all the information of our small triangle. Alright, we slide on over, do this one more time. Alright, what is this angle? It can swing over here because this angle existed, 51, and we swing it over, we have an isosceles triangle, so it's going to create 2 angles that are the same. They're both 51, so this is supplementary to it. This is that same angle. So 180 minus 51.67 51.67, that's going to give us our 128. 128.33. That's the measurement of angle B. It's going to be supplementary to the angle that's next to it, and that angle is going to be equal to the angle we found out here. So now we're going to find the measure of angle C, which is 180, minus our 36, minus this new 128. This is knowing that the angles should add up to 180. That gives us 15.67. 15.67. We're missing one side. So we just use law of sines. 15.67. 9 over sine of 36. Try to do this on your own. Don't try to keep up with me. Pause the video. Try your calculations on your own. See if you're understanding how it all comes together. So C equals 4.14. So we first determined there were two triangles. You could do that by finding the height and comparing it. Or you could come down here and do law of sines, and if you get an angle, then you know that there's going to be two triangles. It's two triangles as long as the opposite side is smaller than the adjacent side. All right, last one. This is 50. Side opposite is 2.8. That means the adjacent side is 4. This is angle B out here. I don't know what's going to happen yet. I could find the height to compare this. Or I could do just law of sines. We'll just pretend like we don't know what we're talking about. We're just going to do our calculations. So the side divided by the angle equals, again, I guess I'm putting the angles on bottom, huh? I'd switch that back and forth a few times. But if I put my unknown on bottom, I have to cross multiply in both directions. I have to do this extra step. That's why in the past I've done a few with my sine of B on top. So what is sine of B? Sine of B is going to be 4 times the sine of 50 divided by 2.8. Oh, look at that. Sine of B equals 1.09. This isn't going to exist. If you just want to test it, you can do the inverse. Sine inverse, and you get an error. You can't have a sign greater than 1. On the unit circle, the y value cannot be more than 1. So if you get a calculation more than 1, that doesn't exist. What that's telling us is that this doesn't even touch the ground. If you wanted to think about it as the height, just to kind of confirm what we're dealing with, we have a height that we're going to try to calculate. We have an angle of 50 and a hypotenuse of 4. So the sine of 50 equals opposite over hypotenuse, multiply by the 4. And we get 4 sine of 50, 3.06. So what that's telling us is that if the height is longer than h, there's no triangle. The a value is greater than h. No, it is less than h. This is your height. Your height is bigger. No triangle. Doesn't exist. It swings short. So you can do this just with law of sines. Determine it because you're getting a sine greater than 1. Or you could look at the height and say, hey, my height is too long. That means my other side doesn't reach. Hope that went well for you.